Hello everyone. I'm going to work through this worksheet on organizing qualitative data. Now, this study is on determining the frequency of majors at a certain college at the Arizona State University. So, the topic is the college in which students are enrolled with more frequency. The following table provides data on college for the students in one section of the course, Introduction to Computer Science at Arizona State University. In the table, we use abbreviations BUS for business, ENG for engineering, and LIB for liberal arts and sciences. So this is the data given to us, and we have to determine the sample size from here, and then also we have to create a frequency table, relative frequency distribution, and go on to graphically representing the data with a bar chart as well as a pie chart. Okay, so we have the data given to us. ENG again stands for engineering, LIB for liberal arts, and BUS for business. And I believe students, a sample of students, were asked, what is your major? And these were the responses which appear to us as raw data. So we have to go ahead and organize the data in a frequency table. Again, this is qualitative data. That means the data came to us in the form of names. These are not numerical data, not quantitative data, but qualitative data. So when we go about creating a frequency distribution, a frequency table, we first list the unique values of our responses of the data set in the first column of the frequency table, which would be in this case majors. So let's list that in alphabetical order. We'll start with business. So let me get my pen out here. Okay, the first one is going to be BUS. Then we have ENG for engineering, and finally LIB for liberal arts or liberal sciences. Then in the next column, we go about creating a tally. That means determining which major occurs how many times in this response set, all right, in the data set. So the first one is ENG. So remember the process. ENG, cross it off so that you don't end up double counting these values. So ENG, I'll put a tally for ENG. Now next one is LIB. Next one is LIB. Business, business, LIB, LIB, ENG, ENG. Again ENG. Then we have LIB, then business, again business, ENG, then business, then ENG. So that's the fifth one. So we have to bundle it by crossing out the four tallies diagonally, all right? So this is a bundle of 5. Next one is again ENG. So we start another bundle. Then BUS, again we bundle that together because that's the fifth one, the fifth appearance of BUS. Then we have LIB, BUS, ENG, BUS, BUS, ENG, ENG. This makes another bundle here. And then 2 more ENGs. And then the last one is business. All right. So now we have completed the tallying process. We are now going to count our tallies and list them numerically in the column for frequency. So for business, we have 5 plus 4, 9. All right. It's easier to count when we bundle our tallies in 5s. For ENG, engineering, it was 5 plus 5, 10 plus 2, 12. And for liberal arts and sciences, it's 4. All right, and then we will sum up all the frequency values, which will give us our value for n. So 9 plus 12 plus 4 is 25. All right, and make sure that the number of data sets you have, the total number of data points you have, equals whatever n is. So we have 5 across for the rows and 5 in columns. So 5 columns and 5 rows. 5 times 5 is 25, and that matches with what we came up with for n, right, when we summed up the frequency values. Now we have to find the relative frequency values. To find the relative frequencies, remember it's a formula. We have to use f over n. So f, the frequency values, go in the numerator, and n, the value of n, which is 25, goes in the denominator. Do the division. So 9 over 25 is 0.36, 12 over 25 is 0.48, and 4 over 25 is 0.16. When you sum up the relative frequency, you can always do a cross check to make sure that the relative frequencies are more or less right. When we sum them up, it should add up to something very close to 1, right? Now, the next part of the question says, construct a pie chart of relative frequency based on your result above, label clearly. So you have to, we have to create a pie chart. In other words, we have to divide this circle into pies. We have to carve pies based on the relative frequencies. All right, now this, because it's a circle, the process we are going to use is to piece up the circle into pies. That's why it's called a pie chart, using the angle. All right, angle and the relative frequency values. All right, so we have to see what angle we should carve out for business majors. All right, so business would be, now the total angle in a circle is 360 degrees. So it's going to be 360 degrees times what is the relative frequency or proportion for business. It's 0.36. So 0.36 is equal to 129.6 degrees. All right, then we have engineering again, 360 degrees. All right, and the relative frequency is 0.48 for a value of 172.8 degrees. And finally we have liberal arts, which is 360 degrees times 0.16 equals 57.6 degrees. Okay, so now we are ready to divide our circle into pieces. All right, so what I'm going to do is I'm going to start with the engineering portion. That's 172.8 degrees, correct? So 172.8 degrees is close to 180 degrees. So what is 180 degrees? It's a straight line. So if we divide our circle from the center, this angle is 180 degrees. 172.8 degrees is slightly less than 180 degrees, correct? So I'm going to make this very, very small. If this is the center, just make this. All right, so we'll have this section of the circle representing engineering. That's engineering, which is going to be 48%, right? Do not write degrees when you're labeling it. Use the relative frequency value or convert that to percentage and say it's 48%. 48%. Now let's do the business. All right, business is 129.6 degrees. So what we are going to do is let's start with 90 degrees. All right, the closest value, 90 degrees. So 90 degrees is this would be 90 degrees, right, with the right angle. This is 90 degrees. And 129.6 is about 40 degrees more than 90 degrees. So it's going to be here. I'm going to try to draw 30 degrees along this angle. Okay, so now let me use my eraser to get rid of these. Okay, so that's going to be roughly our what is it, business, right? So let's write business, and that's 36% from 0.36, 36%, and the rest of it is the liberal arts. Okay, so you don't even need to make any effort to draw it, just erase this line, and we have this as liberal arts, and that's 16%. Okay, and just put a title here. Don't forget your title, which is a pie chart for college majors, distribution of college majors at Arizona State University, or however way you want to write it, please add a title. Okay, so now we go on to the next question, which is construct a bar chart based on your results above. Remember to add a title and label the axis. Now for a pie chart, we have to have a horizontal x-axis and a vertical y-axis. Along the horizontal x-axis, for qualitative data, we have to list our unique values in the data, in this case, the different majors. So we'll start with business, engineering, and liberal arts. All right, so let me do that here. It's business, and then space it out evenly, engineering, and then we will have maybe liberal arts here, liberal. All right, and then if it's a relative frequency bar chart, then you have to list your relative frequency values. Now the highest value we have is, I think, 40.448, correct? 0.48. Yes, 0.48 for engineering. So we can scale our y-axis up to 0.5, and that will contain all the, that will fit all our relative frequency values. So let's divide this in, break it up in intervals of 0.1. So 0.1, 0.2, 0.3, 0.3, 0.4, and 0.5. 0.5. Oops, we have to fix this here. LIB should be here. All right. So business had how much did it have? 36%, right? So 0.36. 0.36 would go up as high as between 0.3 and 0.4 roughly. So we will draw a rectangle around business, and excuse my line, it's hard to draw this digitally. A little bit above, then turn around and drop down. All right. For engineering, it was 48%, so it would go close to 0.5, but not as high as 0.5, a little bit below 0.5, and keep a space between the two rectangular bars when you are creating a bar chart. All right, for histogram, it's a different story. but for bar charts, there has to be a space between the rectangles. So I'm going to start from here, go all the way up to close to 0.5, turn around and drop the line here. So that's engineering. And then for liberal arts, it was 0.16. So we'll have to go somewhere between 0.1 and 0.2, a little bit above halfway between 0.1 and 0.2. So let's do that. Up to here. Well, let me redo this. Okay, so this is our, it's almost, no, this doesn't look right. We have to bring it down a little bit. So let's mark the point, 0.1, 0.2, 0.15 is somewhere in between. So let's make it a little bit higher than 0.15. So go up to this point, turn around, and all right, so close. All right, so we'll try again. Maybe something like this, right? So you have to label and add a title. So the x-axis represents the major, the y-axis the relative frequencies, relative frequency, and please add a title, which would be what? College majors. Okay, college majors of students at Arizona State University. College majors of students at Arizona State University. Now, college majors of 25 students, really. It's not for all students. It was based on a sample. So we have to specify that, or we have to make that clear in our title, college majors of 25 students at Arizona State University. All right. Okay, so that completes this worksheet. You should be working on these on your own, and then come here to make to just ensure that you have worked through it correctly. All right, so just use this as a guide. This is not supposed to replace your work. You're working on this by yourself. All right.